I'm Luke Parrish. I'm a pre-med biochemist, and I'm from Waynesville, Tennessee.
And you are
I'm a freshman.
Today we're going to, go ahead and advance the slide one time over. Talk about universal indicator and how it helps us understand information about solutions. So what I'm going to start with is we have some tap water, and I'm going to use this universal indicator, and what information can you get from this universal indicator with our tap water? What color do you see? Yeah, so we have a green color. Say it again?
It's not fish.
Well, it depends on the fish, but green neutral. And we have here a solution. What does this information from our indicator tell us? Yellow. So what does it tell us about the pH? It's acidic. If I add base, so here I have a dilute solution of sodium hydroxide. We're going to get to, let's all watch and see what happens when I add base. Did this one for TTU. So here, Lucas, what I want you to do is hold this. And I'm going to add universal indicator. This is tap water. Now that we've seen this, what happens with tap water, what do you predict is going to happen when you take universal indicator and add tap water? Yeah, universal indicator to tap water. Yeah, so let's see. Now, chemistry is the study of matter. Matter is just a fancy word for stuff. And the changes it undergoes. So that's the big fun part of chemistry, is what are the changes that matter undergoes. So what we're going to do now, let's go ahead and swirl that. You can give it a better swirl than that. There you go. Give it a little bit more. And then now, what I'm going to do is make it so that you can see a little bit better. I'm going to hold this. Can everybody see? And now, Lucas, what I want you to do is exhale through this solution. Get a big, deep breath. And everybody can see? Keep going, get another breath. Anything happening? Watch closely. So scientists make good observations and careful observations. What's happening? He's got good lungs. So thank you, Lucas. Don't pass out, please. That's good. So we've changed the pH of the solution. The pH has dropped, meaning that this solution is now more what? Acidic. More acidic, right. And so does anybody want to guess why this happened? So I hear a lot of people saying carbon dioxide. Let's test that. Here I have solid carbon dioxide, dry ice. So we have dry ice. Incredibly cold. So I'm going to put a glove on. And I'm going to add, Lucas, can you hold this so that you can see? Got our tap water. I'm going to add some dry ice to our tap water, and what do we observe? Fun. Yeah, that's the water vapor condensing above. And what's happened is the carbon dioxide reacts with the water. It reacts with the water to form carbonic acid. The pH drops. We observe a color change with our universal indicator. So now here what I have are two other solutions. I have a solution A and a solution B. And what we're going to do is add some dry ice to both of them. Make observations. So can you all see these two? What's happening? This one, same observation that we saw here, this is just tap water. I add tap water, I put my dry ice, which is our solid carbon dioxide. The carbon dioxide reacts with the water to form carbonic acid, the pH drops. Now what's happening here? Anybody want to explain this? It's still green, so what do we know about the pH of this solution? Still neutral, so can anybody here explain this? What type of solution do we have? Come on, chemistry. Yell it out.
Buffer.
A buffer, right. A buffer is a solution that resists changes in pH when you add an acid or a base to it. So what we have here is a solution of baking soda and water. Baking soda is sodium bicarbonate, and it acts as a buffer to resist the change in pH from the carbon dioxide. Fun stuff. Acids and bases, universal indicator. You can come and play with this afterwards if you'd like to. It's really exciting when we add a little bit of acid, add a little bit of base, observe the color changes. So I'll turn over to Dr. Swartland.